Hey guys, welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're looking at a situation in which we're going to apply the conservation of momentum. And the situation is that we have a bullet coming fast at 450 meters per second, and it's going to go through this block A here, and it's going to stay embedded or stuck in block B. And what we're trying to find out is the mass of this bullet, the original mass of this bullet, and also the velocity that this bullet had as it was going from A to B. So let's read problem statement and do some analysis on this. A bullet is fired with a horizontal velocity of 450 meters per second through a 3 kilogram block A and becomes embedded in a 2.5 kilogram block B. Knowing that blocks A and B start moving with velocity of 1.5 and 2.7 meters per second respectively, determine the weight of the bullet and its velocity as it travels from block A to block B. Right, so what's the idea here? Well, we could very well, try to do energy conservation here. What would happen is we have the kinetic energy of the bullet, and then as the bullet goes through A, it's going to transfer some of its kinetic energy into A, which is now going to acquire a velocity. But there's a little problem with that. You see that A is actually suspended by these two cables here, right? So what would happen if A started to move, right? I can't just have A going to the right here, right, forever. What happens is it has to go upwards because of those cables. So it can do this kind of movement like a pendulum, right? So if my bullet hits A and A moves to the right, what happens is this. So that means that the kinetic energy of this bullet here is being converted not only into kinetic energy for A, but also into a bit of potential energy for A. A little delta Y here that is due to the movements that the energy taken from the bullet needs also to be accounted for. We don't have any information about this. So this is a situation in which using the conservation of momentum makes more sense. And it's actually simpler in the sense that all we need to do is take like a snapshot of what's the situation before, look at what has happened afterwards, and then just make sure that momentums before and after are the same. Okay, so what do we have before? Let's actually write down the whole thing. So we have the mass of the bullets, and I'm not going to use B because we also have block B, so let's just go for a gun, mass of gun, or mass of projectile maybe, makes more sense, times the velocity of the projectile equals plus the mass of A times the velocity of A before times the mass of B times the velocity of B before. And then afterwards, we're going to have very similar situation in which we have the mass of A times the velocity of A, but now because the bullet is embedded in B, what we actually have is one thing that we consider one single body that has the mass of block B plus the mass of the bullet, and they move with one single velocity because they're one single thing, right? So we would have plus the mass of this new body, which is just the mass of the projectile plus the mass of B times the velocity that this thing has acquired. The velocities are 1.5 for A and 2.7 for B. So we have everything we need because now we can just say, well, if this is the case, then the conservation of momentum tells us that, well, first of all, these guys are at rest before the bullet touches them, so these two are zeros, they go away, and then we have everything else, right? So that means that the mass of a projectile, the bullet, times the 450 meters per second that it had initially has to be equal to the mass of block A, which is 3, times the acquired velocity of block A, plus the mass of projectile that we're trying to find out, plus the mass of B, which is 2.5 kilograms, times the velocity of that B acquired. Cool. So the only unknown that we have here is the mass of the projectile. What I'm going to do is I'm going to send 2.7 subtracting here. So I'm going to have the mass of the projectile times 447.3 has to be equal to 4.5 times whatever this is. It's going to give me 11.25. And so therefore the mass of the projectile is just division between the two, which is 0.02515 kilograms. And then obviously we can take 1,000 to the right, and that's just the same thing as 25.15 grams. 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 Cool, so that's the mass of the bullet. Part A, done. Second part, what is the velocity, back here, what is the velocity of the bullet as it travels from A to B? So now what we want to do is we want to take a different snapshot, a different picture. We want to see the situation when the bullet is here. The before situation is exactly the same. The bullet's coming in at 450. Everything else is at rest. But now we want to know at this instant here what's going on. Well, so at this instant here, the bullet has already gone through block A, right? So that means that block A has already acquired its velocity A. This guy here did not have any contact with the bullet yet, so the velocity of this guy here is 0. And this guy here has a certain velocity, which is definitely smaller than 450 because it gave some of its momentum to A, but it's definitely greater than the 2.7 meters per second that it's going to acquire once it's embedded in B, right? So this velocity here, the velocity that I'm trying to find out, velocity of the projectile 2, call it that way, is definitely smaller than 450, and it's definitely greater than the 2.7. Let's just find out exactly what it is. Okay, so what I want to do is, let me go ahead and copy this to solve part B. So part B. So on the before, nothing changes, but on the after, we don't have B anymore. So we don't have this fella here. It didn't show up, and then we don't have the velocity B. What we do have is velocity of projectile 2, right? So before, nothing changed, and afterwards, we only have two things: the velocity that A acquired from the interaction with the bullet, and the velocity the new velocity of the bullet as it's going from A to B. And again, only one unknown, very straightforward. So that is the 0.02515 kilograms of the bullet that we found out before, times its original velocity, the 450, has to be equal, due to the conservation of momentum, to the mass of A, which is 3 kilograms, times velocity A acquired, which is 1.5, plus the mass of the bullet, 515, times the velocity that the projectile has as it's going from A to B. So nothing fancy here, only one unknown. The velocity of the projectile 2 is approximately 271 meters per second. Actually, 271.079, so let's just go ahead and 27.1, probably more precise. There you go. Cool, so this is the velocity. It's indeed smaller than 450, good sign. It's indeed greater than 2.7, good sign as well. This is the velocity that we get by using conservation of momentum. So this is a very straightforward question, nothing hard, nothing fancy here, but hopefully you understood. And if you have any questions, as per usual, just leave them down below. And if the video helped you out, just give it a like, and we'll talk soon.